I wanted to show you one more example of using a truth table to evaluate the logical validity of an argument. So here's one of our example arguments that we were playing around with last week. If it rains, then I will get wet. It rains, therefore I get wet. So as usual, the first thing that we want to do is come up with some abbreviations just so that we can write this argument a little more simply so that we can actually make a truth table. So for A, let's let A be, it rains. And let's let B be the sentence, I get wet. Okay, so now we can translate this argument into some logical symbols. The first sentence, if it rains, then I will get wet, that's A implies B. The second statement, it rains, that's just A. And then the third, therefore I get wet, so therefore I get wet is just B. Okay, now remember, in an argument, logical statements come in two varieties, two categories. The first are the premises. And the premises are the parts of the argument that you have to grant as true or assume are true to see if the conclusion follows. So the first two of these are premises. And then the second part of an argument, or the second type of statement in an argument, is a conclusion. And in this argument, the conclusion is, I will get wet. So therefore really is just a tag to indicate that the conclusion is, I will get wet. So we have our premises and our conclusion. The next step, remember, to evaluating a logical argument is to write a single sentence that represents the entire argument. Now yesterday in class, the examples we looked at, there was only ever one premise. This argument has two premises. So how do you form the sentence, logical sentence for an entire argument when there's more than one premise? So here's how you do that. Remember, the idea for this sentence is that if the premises are true, then the conclusion is true. That's the sentence that we want to write, this if-then sentence. So when there's more than one premise, really what it means here, if the premises are true, what this means is if all the premises are true. Okay, so our first premise is A implies B. And if we want to say that our second premise is A, if we want to say that both of these are true, we want the first one to be true and the second one to be true. So to write down a sentence that indicates they're both true, we need to put an and in between them like that. And I'm writing parentheses just to indicate that this implication, A implies B, is one piece of the and statement, and the other piece of the and statement is this A here. All right, so the short version of all of this is if you have more than one premise, join them with ands to build up the beginning of your if-then sentence for the entire argument. So we have A implies B and A implies, and now we need our conclusion, and our conclusion is just the sentence B. So our entire logical sentence for the entire argument is A implies B and A implies B. So our next step is to write a truth table for this, to analyze this sentence. So let me put that over here. So the letters in our argument are A and B, so we'll need a column for A and B. Then we need a column for A implies B. And then we need a column for A implies B and A. And then the last column is going to be A implies B, and A implies, and I'll finish writing this once we get to this column, but there should be an implies B over there. Okay, so let's do this truth table. It's hard to draw straight lines on this thing, so sorry that these lines are so wobbly. So since we have two columns for our initial logical variables, each one has two possibilities, and so 2 times 2 is 4, so there's going to be 4 possibilities total. So there's true, 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 false, false, true, and false, false. Okay, and let me try to make these reasonably straight. I did it. Okay. All right, so let's do the if A then B column. So true, true, if true then true, that's true. If true then false, that's false. If false then true, that one's true. And if false then false, that one's true. Okay, so this third column is really just a truth table for implication, which is true, false, true, true. All right, now we can build our truth table for this AND statement. So for this column, keep your eye on the third column and the first column. So we need to AND these two columns together and see when they're both true. So true for the first row, A is true and the implication is true. So true and true, that's true. True and false, that's false. False and true, that's false. And false and true, that's false again. Okay, and now for the final column. Let me finish writing the heading for this final column. This final column is for the logical sentence that represents the entire argument, if premises, then conclusion. So A implies B and A, those are our premises, and our conclusion was B. All right. So let's fill out this column. So we are going to be keeping an eye on the column representing our premises, which is this column here. I'm marking in green. And also, so that's the beginning of our if-then statement. And then the end of our if statement, the then part, is this B column. So we're going to be looking if the premises column, then B. All right, so for this first row, the premises are true and B is true. So if true, then true, that's true. All right, for the second column, the premises are false and the conclusion is false. But if the premises are false, then if then is true. So if false, then false is true. In this third column, the premises are false and the conclusion is true. So if false, then true, that's true. And then in the last row, the premises are false. The conclusion over here is false. And so the implication is true. All right. Now, remember to analyze a logical argument using a truth table. You build this truth table for the sentence representing the logical argument. And if all of these are true, then the argument is valid. So these are all true. So the argument that we started with about me getting wet in the rain, this argument is valid. Remember, the reason that this tells us the argument is valid is because we wrote down all possible situations by writing down all possible combinations of A and B. So we wrote down every possible combination of it raining and me getting wet, and for every possible combination, the sentence representing the argument is true. But that means no matter what the actual situation is, the argument is always true. So it's impossible to make the argument false. That means it's a valid argument. All right, so to summarize what we did here, if you have an argument represent it symbolically, just so that it's easier to write down what the argument is. Write a sentence that represents the entire argument, and that sentence will always be an implication. The conclusion will be at the end of your implication, and the premises are at the beginning of your implication, and all of these sentences representing a premise all get anded together like this. So and together all of your premises, so you can write premises imply conclusion. Once you've written the logical sentence representing your argument, build a truth table. You need one column for each of the letters that you started with, and then maybe some intermediate columns for intermediate calculations, and then a column for the sentence that represents your argument. Fill out the entire truth table, and if your argument column is all true, then the argument is valid.